These two architects have a very tough task. In one of the hottest spots on Earth, they must stop the sun from overheating their towers. They're opening a door that takes design to a whole new level. It's a mesh that wraps the building. Only the north side is open because it never sees the sun. As you'll see, this is no ordinary veil. It's a dazzling new twist on an old Islamic tradition.
We looked at Islamic tradition in terms of the types of devices that have been used to provide shade to buildings in the past, and particularly drew inspiration from the mashrabiyah, which is a traditional Islamic screen.
The mashrabiyah. The idea is to use a geometric pattern to produce shade. The early designs lived up to the old ways, but the boss thought they were too stationary and old-fashioned. He wanted to go further.
It occurred to us that in order to be truly effective in a modern-day idiom, the sun moves around the building in a dynamic fashion, and the facade needed to be capable of responding to the movement of the sun in a similar way.
Senior designer Majid took on the challenge. His solution? Origami.
We took the triangle, we subdivided it into 6 triangles, and then we fold 3 sides inwards, and we folded the three opposing sides outwards. Instantly, he was, Peter was like, "That's it. This is it. We want to do it."
It was the moment when we realized, I think, that we had something special.
The first animations led to ones more sophisticated. They show computerized umbrellas responding to the sun. Here's the view from inside.
We do have the data telling us what the behavior of the sun and the trajectory or the path of the sun is going to be throughout the day and throughout the year.
So 1,000 umbrellas are programmed to automatically open to block the sun, and they close when it is passed.
So if it's early in the morning, let's say, and the sun is low, you will have a complete open strip all the way from the top to the bottom. Now, as the sun starts moving around, the ones that were completely unfold will start folding gradually, while the ones that were now facing the sun, they will unfold completely.
They put up a small section of the system to test it on site. This view from the inside shows that the mashrabiyah is 2 meters from the building. That's far enough for the mesh to block the sun, but let in light.
The mashrabiyah provides about 80% shading.
So you get a view with benefits. One of the first pluses is in the choice of windows. They don't have to be heavily tinted.
So you can have better light transmission, up to 40%, as compared to other buildings in the UAE, where it's down to 15%, 10%, and some of them even as low as 5%. So, ironically, in one of the sunniest and brightest areas of the world, you actually have a poor lit environment. So you have to use the artificial lighting for most of the time.
Not so with the mashrabiyah. And it also means they'll use less air conditioning.
It'll use less energy, so it'll produce less carbon, so it'll respond to all of the challenge which all of us face in this modern age.
Each unit is made of 30 components. The frame is a combination of aluminum and duplex stainless steel.
It has a high resistance to corrosion. This building is facing the sea, so it's a fairly aggressive environment.
The mesh is fiberglass.
But fiberglass alone is not durable enough, so we had to sort of coat it with PTFE, which is a Teflon-based material.
The struts holding the units are stout, weighing 240 kilograms. They have to be. Some units are 6 meters by 4 and weigh more than 600 kilos.
Making sure that this system is structurally robust enough and mechanically reliable enough in order to last for the lifetime of the building. We had to do rigorous testing for the system.
That testing was done in Switzerland. They brought sand, dust, and salt water from Abu Dhabi. They sprayed that mixture on the mashrabiyah and then cranked up the heat to 60 degrees Celsius.
So once this thing dries out, obviously the sand turns into solid mud, and this is really the worst condition that the mechanical components can be subject to.
They ran it for 30,000 cycles, the equivalent of 75 years.
We've only had to change one time the actuator, which is fine. It served for about 25 years. And it's something that we have within our plan, that every 15 to 25 years, we have to change the motors and the actuators, but everything else is still the same.
Next, it faced a wind tunnel in France and its many sensors.
And we put it at the worst condition that we think, it's going to be subject to, and that is when the wind is trying to blow parallel to the mashrabiyah. Because when it's parallel to the mashrabiyah, it provides, the maximum suction effect.
A wind speed of 240 kilometers an hour barely moved it.
We have anticipated roughly up to 50 millimeters, but when we did the wind tunnel, the deflections really did not exceed 25 to 30 millimeters.
And so it's all systems go. Workers are preparing to install the mashrabiyahs. They will attach to those brackets and finally take their place in the sun. As the project nears the end, it's time to reflect on where it began. The owner of the building, the Abu Dhabi Investment Council, wanted a landmark.
They wanted a design which was going to respect the cultural tradition of the architectural heritage in the Middle East, and one which set new environmental standards of design.
Indeed, this may be the point at which the sun sets on one way of building here. Clearly, there's a different way that's a shade better.